All right, this is an example of 5.3.7. It says sketch the shape of a position versus time graph that shows an unbalanced force acting on it. So what I'm going to do is I'm going to go ahead and start with something else. I'm going to start with the acceleration versus time graph. So if I have an unbalanced force, that means that the sum of the forces is equal to some number. Which means if the sum of the forces is equal to some number, that means that I have a mass and I have an acceleration. The key thing being that I have some sort of acceleration. If I had a balanced force, this number would have to be 0. So what that means is I'm going to have some sort of acceleration versus time graph that looks like that. Now remember, when you try and go from an acceleration versus time to a velocity versus time, the slope of a velocity versus time graph gives you the value of acceleration. So let's say this value is 2 for whatever reason. I'm just making up numbers. What that means is that this value right here has to have a slope of 2. Okay, the rise over run value would have to be 2. 2 and 1 in our case. So in this case, I know that by the fact that I have an acceleration value that my velocity versus time graph has to look like this. Now you can extrapolate that a little bit further and you can say, okay, well, what about a position versus time graph? Remember, the slope of a position versus time graph gives you your velocity values, but here's the problem. My velocity values change. So what that means is that the slope has to change as well. So that means I may have something that looks like this. And we talked about this earlier in the year. We said this is the position versus time graph for an object that is accelerating. Okay, it's got this curved movement upwards.